Good morning and once again welcome to my YouTube channel, Pearson at Excel International Maths by Mr. Kamotho. And in this video I want to explain example 4 of binomial expansion, topic number 4 in Pure Mathematics 4. And I will be explaining topic 4 of this book, Pure Mathematics 4. International Advanced Level Mathematics, and I'm on page 34. And in this case, we are expected to find, or rather the function of x is given by 2 plus x all over the root of 1 plus 5x. And part A of the question, we are expected to find the x squared term, find the x squared term in the series expansion of, in the expansion of fx. We have a task there. And part B, we are told to state the range of values. State the range of values of x for which the expansion is valid. The expansion is valid, for which the expansion is valid. And of course, what we need to understand is that the function is in this format, and there is no way we can expand when we have a variable or when we have a denominator, and more so when the denominator contains a variable that is supposed to be expanded. And we need to rewrite it in the form of fx is equals to 2 plus x multiplied by 1 plus 5x raised to power minus a half. You just know what I've done. I've just taken the denominator up there, and because it was root, then the index becomes negative a half. And most conspicuously, you realize that since this is the part of the function that is having an index, it is the part that is going to be expanded. Otherwise, this part will multiply out after we have expanded this part to some extent. And this follows that if we just take this part alone, 1 plus 5x raised to power negative a half, and we compare this with the way we talk of 1 plus nx plus, of course, the expansion is 1 plus our n is negative a half, our x is 5x plus n minus 1 minus a half, and then minus a half minus 1 minus 3 over 2, and then x, we have 5x squared over 2 factorial. Of course, we need to move on and have n minus a half, n minus 1 minus 3 over 2, n minus 2 is going to be minus a half minus 2 is minus 2 and a half, which is minus 5 over 2, and then the x is 5x cubed over 3 factorial. Having said that, it is important to understand the question, find x squared term. And from here, we are up to x cubed term. So we are even beyond the x squared term. So we can stop our expansion there and simplify it at that particular point. So 1 remains 1, minus 1 times 5 minus 5 over 2x, and this one is going to be minus 1 times minus 3, that is going to be 3 times 5 squared, which is 25, so 3 times 25 is going to be 75x squared, and it is plus, because of this negative and this negative, plus 75x squared, everything over 4, everything over 4. Of course, you divide by 2. Dividing by 2 means times 1 over 2 times 1, because 1 over 2 factorial, 2 factorial is 2 times 1. So the whole of this -1, -3, and 25 is all here. Then 2 times 2 happens to be the denominator, and the whole thing is divided by 2, which is just like multiplying by a half. We will get to see what this is all about. But you have seen this is a positive simply because of negative times negative. The third term is going to be minus 1 times minus 3, that is 3 times minus 5, that is minus 15, minus 15 times 125. 125 times 15, which is negative 1875 x cubed all over 2 times 2 times 2, which is all over 8, times 1 over 3 times 2 times 1 over 6. Simplifying this, we're going to get something to do with 1875 divided by 48, we get 625 over 16. So if we wish now to simplify this, we're going to have 1 minus 5 over 2x plus 75x squared over 8 minus 625x cubed over 6, and we can move on and move on. But incidentally, the whole of this was expanded, but we must not forget that it was to be multiplied by 2 plus x. It was to be multiplied by 2 plus x, this part that was not to be expanded. So at that point, we must now get it out, and 2 times 1 is 2, minus, let's just expand this properly, because we need to take or to collect the like term together. Minus 2 times minus 5 over 2 is minus 5x. Let's see whether this is making sense. But we are not supposed to get the term that, we are only supposed to get the term that is having x squared. So even though we expand everything, we will simply be capturing the terms that have x squared. So to me, it would have been easier to have 2 times this, which is, let's say 2 times 75x squared over 8. That is one term. And then we have this times this, x plus x minus 5 over 2x, because that is the other term that is going to have the x squared also. So expanding this, you're going to have 75x squared over 4, 75 x squared over 4, which is now minus 5x squared over 2. minus 5x squared over 2. So if you take the LCM here, it's going to be easily 4, and then 4 divided by 4, that is 175x squared, and then minus 10x squared. So at the end of the day, you realize that 75 minus 10 is going to be 65x squared over 4. And that is the term that is having x squared. So please note we have simplified because we did not want to expand everything. Okay, we would have expanded everything here and capture only the term that are having x squared. But to save time, we have been clever. That times that will give us x squared, and this times this will give us x squared, which we have combined to give us 65x squared over 4. And that is part A. Part B of the question is asking, the expansion is valid. State the range of which the values of the for which the expansion is valid. The expansion is valid. We need to capture this part because now the expansion is valid if the modulus of the value of x, the modulus of 5x is less than 1. Is less than 1. So this follows that the modulus of x is less than 1/5. And that is only when this particular expansion is valid. Otherwise, we would wish to explain further why the expansion is valid only when the modulus of the 5x is less than 1. It's simply because when we keep x here, we find 5x, and of course it cannot be valid if that bracket is negative, and therefore that is when we are talking about less than 1, and the modulus of x is less than 1/5. All right, that is as far as example 4 is concerned. Please be on the lookout for example 5, and of course share widely, subscribe, and let us work together. All right.